Right, a very warm welcome to everyone to EC486 Control Systems. I'll be your instructor for this course. Okay, without further ado, let me just give you a very quick run through to the course. Okay, so here's a very quick course description. In this course, it will be about analysis and design of control system. We will pay particular attention to modeling, state variables representation. I hope you still remember some of this in your previous course. And there will be a lot of emphasis also on computer solution. Okay, so in this case, we will also look at modern design principle. For the undergrads, you will be assigned to lab group and you will actually carry out some lab activity. So for the graduate student, lab work is not within your assessment. So, but of course, you are welcome to join us in the lab if you have any interest. Okay. So the topic that will be covered in this course will include the following listed here. Okay, so I will leave you to take a look at them. Okay. Right. Okay, so this is actually the course objective. Okay, I will just very quickly run through some of the important points. In this course, we really hope that you can acquire this design-oriented approach. So the importance of having that is so that you will develop this ability not just in this course, but also in your continuous study of more advanced topic, because this is actually the first course to control systems, okay, control related course. So we hope that this will actually build some foundation and familiarize you with the basic concept, and eventually will pave the path for you to expand your knowledge further as you move on in your course or in your other more advanced course related control. Okay, so we hope that you are able to master important design methodology, not just the textbook concept, but also able to perform hands-on operation on computer-based analysis. So for the undergrad, of course, you would go through lab. That won't be a problem. For the graduates or the graduate student, you are expected to already have some of this skill in doing computer-based analysis. So in this case, you will actually concentrate more on the academic aspect of the course. Okay, before we go into the lecture in proper, just a very quick self-introduction about myself. So other than teaching control system EC486, I'm also teaching dynamics of mechanical system, ME340. Some of you might have taken this course last year. I also taught introduction to robotics last semester. Okay, some of you might also be in this class who have taken this course. Right. So I won't go into depth about my research, but just to give you a very quick overview of some of the subject that I work on, some of my research interests. Basically three main areas: robotics, vision, and imaging, medical imaging in most cases. So of course, if you are interested in any of this and you would like to speak to someone to know more, you're welcome to talk to me. Okay, outside the class as well. All right. So in teaching this course, I have a very good team of teaching assistant. Okay, so for those who have taken courses like ME340 and EC470, you probably still remember this helpful TA Santosh. Okay, he will be back to also help in this course, and we have two other students as TA as well. One of them is my PhD student, Wang Jiexing, and we also have Wu Xihang as a graduate student this time around to help us in as a TA. Okay, some admin matters, just to very quickly run through it. You should already know the prerequisite. Okay, so most of you will already have fulfilled this, and a recommended reference book. Of course, you don't have to worry because most of the material here in the lecture will be self-contained, uh, but it is always helpful and good to have a reference book, and this is actually the recommended reference book. And you are welcome to arrange any time for consultation, but tentatively I will actually put a time slot on Tuesday 3 to 4. You can find me in E205, the Instructional Control Lab, which is where the undergrads are doing their lab work. Okay, and assessment wise, it will yet to be confirmed, but tentatively it will be 20% homework, 20% midterm, and 30% final. For the lab session, the undergrad will take out 30%, uh, and for the graduate student, you will be doing a project that will also cover 30%. Okay, so lab will be Tuesday and Thursday. Okay, but we will finalize this as the class size finalized. All right. So again, I will leave you to take a closer look at some of the syllabus. Uh, right, sorry, I actually intend to actually show the graduate project, but instead I did the wrong thing. But anyway, this will be your lab session and your homework. For homework, there will be 7 homework, and we will actually grade the best 5 of your 7 homework. All right, so you don't really have to worry if you really need to miss 1 or 2 homework. It will not be penalized. But to encourage you to attempt and finish all homework, there will be bonus mark if you can complete all 7 homework. And of course, you need to score at least 50% for all homework. Okay, at least 50%. So this is actually to prevent some of you finishing the first 5 and decide to just submit empty copy of your 6 and 7 homework. We really encourage you to do all of them. Okay, but as a good as some leeway for you to actually excuse yourself sometime when there's a need, you can actually have 2 homework that will not be penalized without submission. All right, so in the next lecture, we will go into the course material in proper, where we look at feedback control, a very gentle introduction to feedback control. All right, so I'll see you in the next video segment.